Okay, more fun with t-tests. Again, we're still in the Analyze menu. We're still in Module 9. This time we are moving on to Lecture 3D. We are doing another t-test. In today's lecture, we're going to look at a paired samples t-test. Now, you might also see these or read about these as they are referred to sometimes as repeated measures or within subjects. So what we're looking for here, and you can think of this along the lines of repeated measures, is rather than looking at two different groups like we did in the previous lecture, or one group compared to a known population mean in a couple of lectures ago, what we're looking at here is one group before and after, right? So you can think about where we are repeating with the same group or within subjects because we only have one group. So the idea here is we want to compare scores on a group of people. Let's say, for example, and probably most typically, before a treatment compared to after the treatment, right? So we would get some baseline data. We would collect information from them based on something that we're interested in, give them some type of intervention or a treatment, and then again, after that, we would give them the same measure, the same questionnaire, and ask them to respond to it again. And we then would compare the before and after scores to see if there is any difference in those, right? So the paired samples, also the within subjects, and the repeated measures because we are repeating this. Let's, I keep losing, oops, nope, don't want to do that yet. Let's have a look at our data. Now, in order to do this, hopefully you're familiar enough with our data file that we don't have before and after data here, right? This was all these data were collected in this mock file at one time, just to capture perceptions and thoughts and things. So what we're going to do is we're going to create a new one, kind of like we did in the last lecture. And before we get started, real quick, I just want to show that I did indeed keep the age groups variable here. This is the one that we created in our previous lecture when we were going over the independent samples. I'm going to leave that there. In fact, I am going to do a save as at this point, and I'm going to move this on to version 5 and do a save. All right. So now if I write over this and I need to come back to this, I can do that. So let's take a look at what we would be interested in before and after, and how can we make a new variable to indicate before and after scores. I think what I would like to do is continue working with these full measure scores that we have for total, encouragement, full measure. And let's use those in this example as scores before a treatment or before an intervention. And what we need to do is we need to get scores to represent something after we've given the treatments, right? After they've gone through their class, their self-help skills, whatever, increase their self-efficacy or social skills, whatever the case might be, whatever treatment we're giving them. And in order to do that, so we're going to create a new variable. Let's go to transform, and we want to compute a variable. And oops, let's reset this. And what we want to do is take, again, this is just hypothetical. Hopefully, if you are doing a longitudinal or a study over time, you would have your before and after. We're going through this exercise right now only so that we can get a second set of scores for our entire data file or all of our participants. So what I'm going to do here is I'm going to take that total scores on that full encouragement measure. I'm going to bring it over here. And then I'm going to tell SPSS what I want to do is take each individual participant's scores in that measure or that summed score. And I'm going to add, so I'm going to put the plus, and I'm going to add 10 points to everybody, right? And then let's call this total encouragement full measure after. I'm going to put an underscore there. All right, so now, again, this is a long name. You probably would want to find something a little more conducive to, navigating a little more quickly. But now we're going to create a new variable, and it's this after, and each of those, what we should find is that each of their before scores have 10 points added to them for this new variable. So let's go ahead. I think all we need to do is click OK. Our output is going to tell us what it just calculated. And then if we look again at the end of the data file, we can see that we are looking at this one compared to this one, and we can see that yes, in fact, each of these has 10 points added to their scores, right? So we can look at this as before scores, and then we gave them a treatment, some type of intervention, gave them the questionnaire or the test again, got some scores for them, and then this is where the scores that we arrived at after the intervention. Let's go ahead. I'm going to fix this a little bit. I'm going to make this 0 decimals, and let's call this scores on the total scores. What was that? A parenting encouragement inventory, I think, PEI, after treatment. Right, we're going to leave the values alone. The missing, again, we can do the 99. I don't know if I'm going to go in there and manually add the 99s in the data. Columns, I'm going to get rid of columns because I don't know that we need that. No, actually, let's just leave it for now. And let's go over here, and what we see now is, yes, although the decimals have been taken out of our responses here, and now we can run our paired samples t-test, right, because we have before and after scores for each of our participants. Okay, and what we see is when we go then to analyze and compare means, our paired samples t-test, let's reset this, and then we put in, I think I know what we're going to, run into an issue here in just a moment. So, and I'll tell you what that is, what I think that's going to be. Total, right? So this would be the before, and again, let's expand this so we can see. Here's our after. We're just going to bring that over there, right? So variable 1, variable 2, and we're going to see if there are any differences in that. If we click on options, we can see again it brings up our confidence interval. We're just going to leave that the way that it is. We're not going to worry about Bootstrap. We click on OK. I think we may run into an issue here, but let's take a look. Right, so what it's giving us is the mean scores for the before and the after, right? So this is after treatment. And so what we did was when we computed the new variable, all we did was we added 10 points to everyone's total score. So you can see that the mean difference, or the means between the two different, the before and after, is exactly 10. And so that means that we have no standard deviation and we have no standard error of the mean, right? And what SPS is telling us is that it cannot be computed because both of these is 0. Or the difference between these is 0. So I thought about that after a moment. So I think what I'm going to do is I'm just going to go ahead and we cannot have all of these be exactly 10 greater than the before responses or the before scores. So what I'm going to do is I'm just going to take this many, and I'm going to copy these. I'm going to do a Control-C here, and then I'm going to paste. And what we're doing here is we are just changing each of these so that we no longer have all of them being exactly 10 points higher than the original or the scores that we recorded, the mean scores, sorry, the total scores before, right? So that's what I'm doing. I'm just making sure that we have some variance so that those numbers change. And you know what, let's just do this one right here. So again, the only reason that we're doing this is so that we could get two different groups. You may find a better way to do it, but we did learn a good lesson in that. Look, if there's no difference in the standard error and the standard deviation, we can't run that test. Okay, so now that we've done that, let's go ahead and try this again, because now these scores are no longer exactly 10 higher for everybody than those scores. So let's go ahead and analyze, and we're going to go to compare means again, paired samples. Let's reset this. Now we're going to come down here, and we are going to, again, do this one. And now that we've changed the after scores, let's do that and click OK. Right, and now you can see that it did run our analysis for us. So what we're looking at here is we can see our mean scores and the number of participants we have for the before scores, right? And we can see now that the standard deviations are different between the two groups, as is the standard error of the mean. Our mean scores looks like they went up nearly 8 points. So in all, we have 146 participants, right? Which is the number of participants for which we have data both before and after. The correlation, you can see the correlation, that's a strong correlation between the before and after scores, right? And that significance, that would be statistically significant there if we were looking at the correlation. But we, for now, we want to stay focused on, make sure the screen's okay over here. We want to stay focused on right here at the results of the t-test. Okay, and so what we can notice then is this, the mean difference, right? This would be the before and the after. The difference in those means is 7.884, which we would get if we were to run that, to subtract the before from the after. I'm not going to necessarily worry about the standard deviation right now, but it does have to do with the difference between the mean scores. The standard error of the mean, I'm not going to necessarily worry about that right now for reporting purposes as well. But let's move on to the t-value. You can see we have a negative 2.757. And here's our degrees of freedom. So if you remember, the degrees of freedom is the number of participants we have, the number of cases, minus the number of groups. And again, here we have only one group, much like we did a couple of lectures ago when we were comparing to a known population mean, but different than the previous lecture in which we were comparing two groups. So we have only one group this time. So our degrees of freedom are the 146 minus one group for 145. Then you can see we have our significance, our significance value, our p-value here of 0.007. And again, if we were using an alpha level of 0.005 to determine and report significance, we can clearly see that yes, in fact, this difference is statistically significant. So the reason that we have the negative value here is because of the mean scores for the before group were less than the scores for the after analysis, right? For the mean scores after treatment. If these scores here had in fact gone down, what we would see is a positive t here. We don't necessarily have to worry about that. What we're mostly worried about is the 0.007 here. So it's perfectly fine to have a negative t value. And again, our 95% confidence interval, you can take a look at that there. Let me pull up a Word document real quick, and we will take a look at writing this up. Okay, hold on one second. Let me pull up a doc. Okay, so I've started to write this out, and it's going to look similar to the write-ups that we've done with the other t-tests. So just as a starting point, what we have here is a paired samples t-test was conducted to compare something in group 1 compared to group 2. Now we have only one group. This is only a template. And then again, much like we did in the previous write-up, results showed that baseline total scores on the PEI, and then we're going to give the mean and the standard deviation, were higher or lower than total scores after treatment. And then again, the mean and the standard deviation, and then we will give our results as far as the t-value, the degrees of freedom, and the p-value. So let's go ahead and finish this out. Or if you want, go ahead and put it on pause for just a moment and write it out yourself, just kind of as a practice, and then flip it back on and see how you did as far as this goes. So let's see. A paired samples t-test was conducted to compare baseline and after treatment scores on the PEI for the entire sample. Right, and then we can just go ahead and get rid of this. As I said, this was just a template, so let's go ahead and get rid of that. Results showed that the baseline total scores on the PEI, and let's put in our mean. Baseline was, here's our baseline, if you remember, right here, the 151. So 151.25, 151.25, not enter 25, and then the standard deviation we see is 37.767. We're lower, right? So we'll just put that in there. Those scores were lower than total scores after treatment. And then we're going to again put in the mean here, 159.14, and the standard deviation is 39.643. And then again, as we see down here in our table, the mean difference and I believe the standard deviation difference is, that's not our standard deviation difference. We're not going to worry about the standard deviation difference, but the mean difference, our readers can see the 151 and the 159 and change. The difference between those is our mean difference. And then so what we will write is T, and then our degrees of freedom are 145 equals, T value is negative 2.757, and then our P value is equal to 0. Let's do 0.007, and then our readers will know that that is a statistically significant, and we could even write in here we're lower, and we could write here which was a statistically significant. We could even write that in there just to be very explicit. The results showed that the baseline total scores on the PEI were lower than total scores after treatment, which was a statistically significant difference. And that's how we indicate the difference there. Again, the negative T value that we got right here is perfectly acceptable. If these scores had been mixed, or if we were measuring something else, the reason that we have a negative score is because the initial scores, the baseline scores, were lower than the after treatment scores. And if we were to reverse these two here, then we would get the exact same values, except that would be positive. So that's that. Again, thanks for sticking with. And we realized our error in having all of our post-treatment scores be exactly 10 higher than the pre-treatment, than the baseline scores. And that's again because we had 0 difference in the standard deviation and the standard error. So yeah, we just had to make that adjustment there. But again, that wraps up all of our t-tests. So we have gone over. Let me just kind of review those real quick. We went over in as far as t-tests. First, the independent samples. First we went over the one sample, right? That was one group compared to a known population mean. Then we did the independent samples, right? And that's when we divided our sample data into men according to 2 different age groups and ran a test to see differences there. And then the paired samples, again, in this one we were using one group on 2 different assessments or 2 different time points before and after. So that's where we've gone with that. And you can see we are now going to move on to 3E. We're going to remain in the comparing means section, but we're going to move on to a one-way ANOVA. And as we continue, let me just give a reminder that this is not a statistics course. This is a course on knowing how to use SPSS, how to read the outputs, how to do the functions. We do, as you've just seen, we do the write-ups when we can, and we will continue to do that. But again, the main function of this course is to understand SPSS, where to find what you need, how to do it, and then how to interpret a little bit. So when we start to get into some more of the in-depth things, for example, ANOVAs and some of the more complex regressions and factor analysis and tasks like that. Just know that there will be, certain things that you probably would be expected to already know, or, to be able to fill in some of the gaps, only because this is not a stats course, it's an SPSS course. Okay, hope I've made that disclaimer clear well enough. What I'm going to do between lectures is I'm going to save a new file version here as 0.06, and so when we get back, we will work on the one-way ANOVA. It's been great to have you kids in class, and we'll close a file here, and I will see you real soon. Bye.